In this video, we will learn how to write the equation of a line parallel or perpendicular to another line. We'll consider cases where we already know the slope, and we'll also look at cases where we're given 2 points and we need to find the slope of that line before finding the slope of a parallel or perpendicular line. But first, let's review a few things about lines. Y equals mx plus b is a general form for a straight line equation, and in particular we call this the slope-intercept form. In this form, the coefficient of x, the m variable, is the slope, and b equals the y-intercept, the place where this function crosses the y-axis. As we said on the first slide, we want to consider parallel lines and perpendicular lines. We know parallel lines never intersect one another. They never cross. We usually represent that with a small triangle on either line. And occasionally, when there's more than one pair of parallel lines, you might see them noted with a multiple of the little triangles. In that case, the parallel lines will be the pair with the matching symbols. What we're showing are 2 sets of parallel lines. It's also worth noting that you might see this parallel symbol used to represent parallel lines. Here, line segment AB is parallel to line segment CD. But the most important thing to remember about parallel lines is that they have the same slope. If we look at straight line equations given in slope-intercept form, and they have the same value for the variable m for the coefficient of x, they will be parallel. Now let's consider what perpendicular lines are. Perpendicular lines intersect at a 90-degree angle, and this is often noted with the right angle symbol. Now, the set of perpendicular lines that I've drawn here are horizontal and vertical, but this is not always the case. Perpendicular lines can occur at any orientation, and when it comes to the slope of perpendicular lines, they are negative reciprocals of one another. So parallel lines have the same slope, their m values are the same, and in perpendicular lines, if one of the lines has a slope of m, the other line will have the negative reciprocal, which is -1 over m. It's also worth noting here that there are lines that intersect that are neither parallel or perpendicular. Lines that intersect, forming any angle besides a right angle, do not fit in the category parallel or perpendicular. Let's use this information to start working with the equations of parallel and perpendicular lines. Determine whether the lines y equals -1/7 x minus 5 and y equals -1/7 x minus 1 are parallel, perpendicular, or neither. The categories parallel, perpendicular, or neither are all ways we categorize intersections of lines. Parallel lines do not intersect. Perpendicular lines intersect at a 90-degree angle. The category neither here represents all the lines that do intersect but do not form a 90-degree angle. Parallel, perpendicular, or neither. But we're not given a graph for these 2 lines. Of course, we could try and draw a graph for both of these lines, but we can determine parallel, perpendicular, or neither without graphing these 2 equations. Both of these straight lines are given in the form y equals mx plus b. In both cases, the coefficient of x, the m variable, is -1/7. The m variable represents the slope, and so we can say that the slope of line 1 is -1/7 and the slope of line 2 is -1/7. Which reminds us, parallel lines have the same slope. That is why they do not intersect. Since both of these lines have a slope of -1/7, we can classify them as parallel lines without graphing. In this example, we'll again be classifying lines, but this time we're not given the equations of the lines. We're only given 2 points that lie on each of the lines. Given that the coordinates of the points A, B, C, and D are -15, 8, -6, 10, -8, -7, and -6, -16 respectively, determine whether line AB and line CD are parallel, perpendicular, or neither. Points A and B fall on the line AB, and points C and D fall on the line CD. To classify the lines, we have to remember parallel lines have the same slope and they do not intersect. Perpendicular lines have negative reciprocal slopes and intersect at a 90-degree angle. And neither are lines that are not parallel or perpendicular. Lines that do intersect but do not form a right angle. This means to consider whether or not these lines are parallel or perpendicular, we need to know the slopes of these lines. In the general form, y equals mx plus b, the m represents the slope. And we can find the slope m if we have 2 points by saying m equals y2 minus y1 over x2 minus x1. In order to categorize these lines, we need to find the slopes of line AB and line CD. We can start with line AB, let point A be x1, y1, and point B be x2, y2. Then the slope will be 10 minus 8 over negative 6 minus negative 15. 10 minus 8 is 2. Negative 6 minus negative 15 is negative 6 plus 15, which is positive 9. So we can say that the slope of line AB is 2/9. We repeat this process for line CD. Let C be x1, y1, and D be x2, y2, and we'll get m equals negative 16 minus negative 7 over negative 6 minus negative 8. Negative 16 minus negative 7 is negative 16 plus 7, which is negative 9. Negative 6 minus negative 8 is negative 6 plus 8, which is 2. The slope of line CD is then negative 9 over 2. If we compare these two slopes, negative 9 over 2 is the negative reciprocal of 2 over 9. And if you weren't sure, you can multiply them together. Reciprocals multiply together to equal 1, and negative reciprocals multiply together to equal negative 1. These two slopes are the negative reciprocals of one another, making these lines perpendicular. Here's another example. Which axis is the straight line y equals 3 parallel to? First, we note that parallel lines do not intersect, and they have the same slope. We have the equation y equals 3. If we think about the general form for a straight line, y equals mx plus b, and we have y equals 3, which means that we have a slope of 0. From there, if we sketch a y and x axis, graphing the line y equals 3 would look like this. We should notice here that the line y equals 3 crosses the y-axis, and we know that's true because it has a b value of 3, and in the general form, the b represents the y-intercept. We can therefore say that the straight line y equals 3 is not parallel to the y-axis because it intersects the y-axis. But we can say that y equals 3 is parallel to the x-axis. The x-axis is the line where y equals 0. The straight line y equals 3 is parallel to the x-axis. In the next example, we need to find the equation of a line if we're given a point on that line and then 2 points on a line perpendicular to that line. Determine in slope-intercept form the equation of the line passing through A, 13, negative 7, perpendicular to the line passing through B, 8, negative 9, and C, negative 8, 10. So here's what we're thinking. We have points B and C, which form a line. Point A does not fall on this line, but point A falls on a line perpendicular to the line BC, and we're trying to find, in slope-intercept form, the equation of the line that passes through point A. Slope-intercept form is the form y equals mx plus b. That means we need the slope of this line and the y-intercept. But since we don't know 2 points along this line, we'll have to find the slope a different way. We remember perpendicular lines have negative reciprocal slopes, and since we do know 2 points along the line BC, we can find the slope of line BC, and the slope along the line that includes point A will be equal to negative 1 over the slope of the line from BC. This is just a mathematical way to say that these two values will be negative reciprocals of one another. This means our first job is to find the slope of line BC. If we know 2 points along a line, we can find their slope by taking y2 minus y1 over x2 minus x1. We'll let b be x1, y1, and c be x2, y2. And the slope of line BC will be equal to 10 minus negative 9 over negative 8 minus 8. 10 minus negative 9 is 19, and negative 8 minus 8 equals negative 16. We can say that the slope of line BC is 19 over negative 16, but more commonly we would include the negative sign in the numerator and say the slope of line BC equals negative 19 over 16. The slope of the line containing point A is the negative reciprocal of this value. To find the reciprocal of a fraction, we flip it. The reciprocal of negative 19 over 16 is 16 over negative 19, but we have to be careful here because we need the negative reciprocal. And that means negative 16 over negative 19 simplifies to 16 over 19. The slope of the line passing through point A is then 16 over 19. At this point, we have the slope of the line passing through point A, and we have one point that falls along that line. To find the y-intercept form of this equation, we could then use the point-slope formula, which says y minus y1 equals m times x minus x1, where x1, y1 is a point along the line. Point A is x1, y1, and so we have y minus negative 7 equals 16 over 19 times x minus 13. Minus negative 7 is plus 7. We distribute that 16 over 19 times x. And 16 over 19 times negative 13 equals negative 208 over 19. Since we want the equation in slope-intercept form, we need to get y by itself by subtracting 7 from both sides. Negative 208 over 19 minus 7 is negative 341 over 19. This line, y equals 16 over 19x minus 341 over 19, is perpendicular to the line BC and passes through point A. Here's another example involving parallel lines. The straight lines 8x plus 5y equals 8 and 8x plus ay equals negative 8 are parallel. What is the value of a? We know that parallel lines have the same slope, and in slope-intercept form, y equals mx plus b, the coefficient of the x variable m represents the slope. We've been told that these two lines are parallel, and that means they will have the same slope. To find the slope of these lines, we'll convert them to slope-intercept form. To do that, we get y by itself. Since both equations have 8x on the left, we'll subtract 8x from both sides of both equations. On the left, we would have 5y equals negative 8x plus 8. And on the right, ay equals negative 8x minus 8. We need to get y by itself for slope-intercept form, so we can divide through by 5. And the equation on the left in slope-intercept form will be y equals negative 8/5 x plus 8/5. On the right, we need to do something similar. To get y by itself, we'll divide through by a, and our second equation will be y equals negative 8 over a x minus 8 over a. These slopes have to be equal to each other if these lines are parallel. Since one of the slopes is negative 8 over 5, the other slope will need to be negative 8 over 5. And that tells us that a must be 5 for these two lines to be parallel. If we go back in and plug in 5 for a, we see that the ratio of coefficients between these two equations are equal to each other, which makes them parallel. In our final example, we're given 3 points that form a right-angled triangle, and we'll use what we know about parallel or perpendicular lines to solve for a missing value in one of the points. Suppose that the points A, negative 3, negative 1, B, 1, 2, and C, 7y, form a right-angled triangle at B. What is the value of y? We can go ahead and make a sketch of these points. A is negative 3, negative 1, B is 1, 2. We know the x-coordinate of point C is 7, and that means C will be located somewhere along this line. We know the line AB, and we've been told that the right angle of this triangle is at point B. We can get a general idea of where we think point C would be, but this is not a good way to find an accurate answer. But because we know this is a right triangle, we could say that line AB is perpendicular to line BC, and That means the slope of line segment BC is the negative reciprocal of the slope of line segment AB. To solve this problem, we'll need to do three things. First, find the slope of line segment AB. Use that slope to find the negative reciprocal, which is the slope of line segment BC. Then take the slope of line BC and use that to find the y value in point C. If we have 2 points, we find the slope by using m equals y2 minus y1 over x2 minus x1. For the points A and B, that would be 2 minus negative 1 over 1 minus negative 3, which equals 3/4. The slope of line AB is then 3/4. And we've completed step 1. For step 2, we need to take the negative reciprocal of the slope we found in step 1. The negative reciprocal of 3/4 is negative 4/3. And that is step 2. Now for step 3, we'll take point B, 1, 2, and point C, 7y. We'll let B be x1, y1, and C be x2, y2. The slope, negative 4/3, is equal to y minus 2 over 7 minus 1. 7 minus 1 is 6. To solve this, we cross multiply. Negative 4 times 6 equals 3 times y minus 2. Negative 24 equals 3y minus 6. Give us a bit more room. To solve for y, we add 6 to both sides, and we get negative 18 equals 3y. Divide both sides of the equation by 3, and we get negative 6 equals y. And we found from step 3 that y must be equal to negative 6. This means for this to be a right triangle, point C needs to be located at 7, negative 6. And so we found that missing value to be negative 6. To wrap up, we'll review our key points. Parallel lines do not intersect and have the same slope. Perpendicular lines intersect at a 90-degree angle and have negative reciprocal slopes of one another.